example, 1, 3, 5, 7, 9. They're separated by commas. So this is an example of a sequence. If I put, instead of commas, pluses or minuses like 1 plus 3 plus 5 plus 7 plus 9, etc., now it's called a series. So you got the title of this is Sequences and Series. Now we're going to develop a whole slew of formulas, probably 10 formulas. 5 for each of 2 types of sequences that we're going to hit really hard. Arithmetic sequences and geometric sequences. Now there are plenty of other kinds, but those are the 2 we're going to concentrate on. And the 10 formulas that you'll be using will be on the board when you take your test. You can write them down if you want them close by, whatever. You don't have to memorize anything. So what is it that makes the test difficult? Well, you have to know what formula does what. Okay, so if I asked you to find the 37th term of an arithmetic sequence whose first term is whatever, then you got to say, okay, which formula do I want here? And sometimes you can't get a formula to get you the answer right away. You have to use a formula to get something you don't know, and then after you get that, you can get whatever it is you're trying to find. So sometimes it takes more than one formula. So the whole thing isn't about memorizing formulas. It's about knowing what they're good for, okay? What they can do for you. And some of them are extremely powerful formulas, as you will see. I mean, I could ask you, for example, what the 100th term of this is. Well, this would be easy, but you know, in general, it's not going to be that easy. And you can instantly find it using the right formula. Okay, in this situation, this first term, I'll be using a sub 1. Your book will use t sub 1, but all 9 books out of 10 use a instead of t. This last term, if I erase the 3 dots and just stop with that. So in this case, the last term, a sub n, where n is the number of terms. So that n is number of terms, then a sub n, so in this case 5 terms, a sub 5 would be the last term, 9. Okay, so a sub n in this case is a sub 5, which is 9. In this case, a sub 1 is 1. Now, mathematically, how do I get from one term to the next here?
You add 2.
I add 2. That's what makes it an arithmetic sequence. And you spell arithmetic exactly the way you spell arithmetic. But when it's an adjective, it takes a different pronunciation. Okay, so in this case, the common difference, which we call D, is 2. And you can generally tell what it is by inspection for an arithmetic sequence. Just what am I adding each time? If the numbers are getting smaller, then D is negative. You're adding a negative number each time. Okay? S sub n is the 5th and final quantity that will show up in any of the formulas. And it's the sum of the first n terms. So in this, if I ask for S sub 3, I'm asking for the sum of 1, 3, and 5, the first 3 terms. S sub 4 would be 1 plus 3 plus 5 plus 7, the first 4 terms, and so it goes. So S sub whatever is the sum of the first that many terms. All right, so these are the notations then for the 5 quantities associated with arithmetic sequences or series. First term, last term, number of terms, the common difference, and the sum of the first n terms. Now, of the 2 main types, geometric sequence of series, which I'll call geometric progression, but I don't care whether it's a sequence or a series, is where you multiply by the same thing every time. So if I've got, let's say 2, 6, 18, 54, 162, etc. This is an example of a geometric sequence. And so it's pretty obvious that there is no common difference. What is it that remains constant in this case?
3.
Okay, you're multiplied by 3 each time. And to figure that out, you can take 6 over 2, or you can take 18 over 6, or whatever. So R is the common ratio. And again, you can usually get it by inspection. Just find the two simplest terms back to back, take the second of those two divided by the previous term, and you get the common ratio. Everything else for geometric progressions is the same as you see here. We still have a last term, number of terms, first term, and the sum of the first n terms. So those four things do not change, but R is characteristic of a geometric progression, and D is characteristic of an arithmetic progression. So if you see a formula with D in it, you know it's arithmetic right away. See a formula with R in it, you know it's geometric right away. Okay? Before we look at some of what's in here, let me give you a couple of literal sequences. See if you can tell me the next letter in this, unless somebody already told you from period 3. Somebody tell me what the next term in this, what the next letter would be?
E.
It is not E.
O.
It is not O.
F.
We could just run down the line, but how do you figure it out? What? It's not E.
D.
D. It's not D.
Why would there be D? There's so many D's there.
X.
One, these are not
Y.
numerals, these are
Because you're-
What?
letters. No, that's O.
Oh.
O, T, T, F, F, S, S, those are all
You have to
letters.
count how many
E.
letters
E.
it has.
Might be the number that they're
1, 2,
K.
2.
Did I give you this last year, Kevin? You're trying to remember what I told you last year? All right, well, Kevin's trying to remember from last year.
F1.
It's J,
You want
H.
S?
All right, let me give you the hint that I always give,
H for
and
hill.
somebody always uses to
No?
figure it out. Count the letters from left to right slowly to yourself.
1, 2.
To yourself.
Oh, I get it.
I still get it. I really don't.
Oh, wait.
I got it.
Oh.
Andrew, you got it?
N.
N is the next letter. Okay, don't say anything. Somebody tell me the next letter after N.
WTF.
Wow. Appropriate.
What is R?
What is
T.
this? No.
X.
M.
You didn't hear though.
Say it again.
T. W. I said 3 times.
T.
W.
It is T, yes.
Oh, you got it right.
Yes, I heard from Cindy.
Probably heard Andy.
No, it's easy. Is this math or is like?
This is math, yes. You're finding a pattern.
You get it?
Patterns play a huge role in this
Yeah.
chapter.
He said what? Think of how you
Patterns play a
think of
huge
the
role.
number
This is
and then
necessary for what you're
A,
learning.
B, C, D.
Oh.
letter bar. You do the
It's like,
Maybe letter bar. I don't.
oh,
Just count.
no.
Just count.
Is he next?
That's what I told him, Andrew. Why does
Don't stress.
Yeah.
What's that?
Is this a arithmetic sequence?
Arithmetic sequence?
Oh,
You get it.
What's the number for O?
No, just spell some secret
What?
code. Oh my god. Look at the letters. You'd be surprised.
Just count while you look at it.
1, 2, 3,
F,
4,
F,
5,
F,
6,
F,
7,
Don't say anything.
9.
Don't say
Just
anything.
don't look at it.
Okay, look at the words, actually. Look at the words of the numbers.
You're doing it.
Wait.
You get it?
Oh, 1, 2, 2, 3.
No, I don't get it.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I get it.
3, 4, 5.
Where's my hat?
Oh wow.
Ah!
Oh my god! I got it! What? I'm bad with riddles, guys.
You said, take the three.
From the ball, guys.
Ah.
Did you
One
quit
is from the
action?
O, 2 is from the T, 3 is from the
You're
E,
super
4
young.
is from the F.
Stop looking at me.
6
Yes.
is from F, 7 is F.
Okay, Tanya's figured
Your
it out.
reactions
You
are
want to
funny.
explain it, Tanya?
Is this, I don't think this is necessary.
Well,
Let Johnny explain it.
No? Tanya doesn't want to explain it.
Johnny.
It's
Johnny, explain
O is for 1, 2 is for 6.
Okay, you're looking at the first letter of the spelling of each number. 1 starts with O, 2 and 3 start with T, 4 and 5 start with F, and so on. So you're looking at the initial letter of the spelling of the numeral. Okay? All right, here's a little different